So we need to find the cotangent of 15 degrees, because pi over 12 is 15 degrees. I've written a couple of formulas on the right here that we might use to do that. So we have cotangent of 15 degrees. Now that's the same as 60 degrees minus 45 degrees. So we find two angles whose measurements we know and write the 15 degrees as the sum or difference of those angles. And there's a couple ways you can do that. I just picked 60 degrees and 45 degrees, but there's other ways. So this is the same as 1 over tangent of 60 degrees minus 45 degrees. So cotangent and tangent are reciprocal functions. And using the tangent allows me to use one of the formulas that I have up on the right here. So in our formula we have a minus, so we'll be using this formula with the minus. So we have 1 over tangent of s. Let me rewrite that once. 1 over tangent of s minus tangent of t over 1 plus tangent of s times tangent of t. And then that's just the reciprocal, so that just flips the denominator, right? You invert and multiply and you get the 1 plus tangent of s times tangent of t over tangent of s minus tangent of t. Okay, so let's go ahead and figure out our s and t. The s was the first term, so that's the 60 degrees, and the t is the second term, so that's the 45 degrees. So let's fill those in. So 1 plus tangent of 60 degrees times tangent of 45 degrees over tangent of 60 degrees minus tangent of 45 degrees. So you can go ahead and draw the triangles for that. I'm getting a little squished on the paper, so I'm not going to draw that. But you can draw the figures and figure out that the tangent of 60 degrees, that would be square root of 3. And the tangent of 45 degrees is 1. And then in the denominator we're subtracting. So square root of 3 minus 1. We should rationalize our denominator, so we'll multiply it by the conjugate, square root of 3 plus the square root of 1. Rather, square root of 3 plus 1 over square root of 3 plus 1. So we'll go ahead and multiply that out using FOIL. We get first term square root of 3, outer terms 1, inner terms 3, and last square root of 3. In the denominator, first terms would be 3. Outers and inners are opposites, so they add to 0. So I get a 3 minus 1 there. So we have 2 square roots of 3 plus 4 over 2. And so that reduces to be square root of 3 plus 2. So if you're working with a reciprocal function, secant, cosecant, or cotangent, you'll have to switch it and use 1 over the proper trig function. But then you can use the correct sum or difference formula to find your answer.